Welcome to Spaceverse, your portal to cosmic adventures. In 2017, astronomers detected something extraordinary. An interstellar object later named Oumuamua had entered our solar system. It was fast, it was strange, and it defied expectations. Oumuamua wasn't like anything we had ever seen before. It wasn't bound to the sun, its shape seemed elongated and bizarre, and its motion hinted at forces we couldn't fully explain. For a while, it even sparked speculation that it might not be entirely natural. 2 years later, in 2019, the discovery of Comet 2I Borisov confirmed that Oumuamua wasn't just a one-time cosmic accident. Interstellar visitors really do pass through our neighborhood. Borisov, unlike Oumuamua, looked much more like a typical comet, shedding gas and dust as it approached the sun. But together, these two discoveries changed our view of the solar system forever. Suddenly, we weren't just looking outward at other star systems, we realized that sometimes pieces of those systems come to us. And now, in 2025, it has happened again. A new interstellar object has appeared on the radar, and it's been given the provisional designation A11PI3Z. Unlike Oumuamua, which we only noticed 5 days after it had already swung past Earth, this time we're ready. Spotted on July 1, 2025, and listed by the International Astronomical Union's Minor Planet Center, A11PI3Z immediately raised eyebrows across the astronomical community. It first showed up on the Near-Earth Object Confirmation page, flagged for follow-up observations. At first, it might have looked like just another rock on a long orbit. But the moment astronomers began fitting a trajectory, the signs were clear. This object isn't from around here. Its orbital path turned out to be sharply hyperbolic, meaning it's not gravitationally bound to the sun. That's the defining signature of an interstellar object. And not only that, but preliminary calculations suggest an eccentricity of around 6. For context, most solar system objects, like asteroids and comets, have eccentricities between 0 and 1. Oumuamua, for example, had an eccentricity of about 1.2. This new object's eccentricity of 6 is extreme, the highest ever recorded for any object passing through our solar system. That confirmed what many suspected from the start. A11PI3Z isn't just interstellar, it's on one of the most dramatic interstellar paths ever detected. Now, astronomers classify an object as interstellar if it travels faster than 42 kilometers per second, the minimum speed needed to escape the sun's gravitational grip. A11PI3Z's incoming speed is roughly 66 kilometers per second relative to the sun. That's well above the escape velocity. It means there's no question this visitor will not stick around. But to be sure, astronomers needed more data points. Not long after the initial detection, early images were uncovered in archival ATLAS survey data dating back to June 25th. With those extra observations, scientists could run more reliable orbital fits. And the evidence only grew stronger. This was, without a doubt, an interstellar visitor. The Minor Planet Center has now officially cataloged the object as 3I Atlas, marking it as the third confirmed interstellar object ever detected in the solar system. And its trajectory tells us quite a bit. 3I Atlas will reach its closest approach to the Sun, called perihelion, on October 27, 2025, at about 1.4 astronomical units. That's just a little farther than Earth's distance from the Sun. Unfortunately, Earth will be on the other side of the Sun when that happens, meaning we won't get a front row seat. But on December 17, 2025, it will make its closest approach to Earth at a distance of 2.4 astronomical units. That's still safe, far enough away to pose no danger, but close enough for telescopes to track and study it in detail. After that, it will keep moving outward, passing near Jupiter's orbit around March 10, 2026, and then disappearing forever into interstellar space. So, what do we know about it so far? Early images show 3I Atlas at a visual magnitude of around 18.8. Based on its brightness, and assuming it has a typical reflectivity, astronomers estimate it could be about 20 kilometers wide. That's enormous compared to Oumuamua, which was maybe a few hundred meters long, and even bigger than Borisov, which was about a kilometer or two in size. If the size estimates hold, this would make 3I Atlas the largest interstellar object ever observed. But there's a catch. The true size depends heavily on how reflective the surface is or whether it's emitting gas. If it's covered in bright ice, it could be much smaller than 20 kilometers. If it's dark like charcoal, it could be even larger. And if it's releasing gas as it warms up, that could make it appear brighter, skewing size estimates. This is where things get especially intriguing. If astronomers detect any non-gravitational acceleration, like what was seen with Oumuamua, it could open a whole new line of investigation. In Oumuamua's case, the object seemed to accelerate slightly without any visible signs of outgassing, which puzzled scientists and even inspired exotic theories about artificial origins. With 3I Atlas, if we observe something similar, it could either confirm that many interstellar visitors behave this way or deepen the mystery. That's why all eyes are turning toward the James Webb Space Telescope. With its powerful infrared vision, Webb could detect thermal emissions from 3I Atlas, helping to measure its temperature, size, and maybe even its shape. Combined with spectroscopic studies from ground-based telescopes, we may learn whether it's a comet releasing gas, a rocky asteroid, or something entirely unexpected. Another curious feature is the object's inclination, nearly 175 degrees. That means it's moving almost directly opposite to the planets of our solar system. It's a steep, dramatic angle that all but guarantees it's not native to our system. In fact, the orientation of its orbit suggests it may have originated in the Milky Way's stellar disk, the flat plane where most stars reside. And that opens up an exciting possibility. If we can measure its incoming velocity and direction precisely enough, we might actually trace it back to the star system it came from. Imagine being able to say, this rock passed through our solar system, and here's the star it likely formed around. That would be an incredible achievement in interstellar archaeology. Of course, we don't have forever. 3I Atlas will only be within observing range for a short time. It may brighten as it approaches the sun, but with Earth out of position during perihelion, we'll need to make the most of the windows we do get. Ground-based telescopes, space observatories like JWST, and upcoming instruments like the Vera Rubin Observatory will all play a role in studying it. Already, some reports suggest possible signs of cometary activity, though it's still too early to confirm. And speaking of Rubin, this discovery couldn't have come at a better time. Over 400 years ago, Galileo pointed his telescope at the sky and revolutionized astronomy. Today, we're on the edge of another shift, thanks to the Vera Rubin Observatory, which has just begun its decade-long legacy survey of space and time. Rubin is designed to scan the sky repeatedly, night after night, catching everything that moves or changes. That means asteroids streaking by, stars flaring or dimming, supernovae exploding, even potential signals of dark matter and dark energy. It's named after Vera Rubin, who provided the first convincing evidence for dark matter when she noticed that galaxies were spinning in ways that defied Newtonian physics. Without something invisible holding them together, those galaxies should have flown apart. Her work changed cosmology forever, and the observatory carrying her name is poised to do the same for the next generation. At the heart of Rubin is the largest digital camera ever built for astronomy, 3.2 gigapixels. That's 189 ultra-sensitive sensors chilled to -48 degrees Fahrenheit to reduce noise, arranged into modules the size of a small car. Each exposure covers 3.5 degrees of the sky, wide enough to fit 7 full moons side by side. It takes just 15 seconds to capture a shot and 2 seconds to download it. And then Rubin compares each new image to previous ones, flagging anything new within about a minute. The LSST has 4 main goals. First, to study dark matter and dark energy by mapping billions of galaxies and tracking cosmic expansion. Second, to watch the sky in motion, detecting supernovae, gamma-ray bursts, flickering quasars, and other fast-changing events. Third, planetary defense, tracking near-Earth objects to protect our planet. And fourth, cataloging the solar system, from asteroids to distant Kuiper Belt objects. Even in its first few test runs, Rubin has already delivered stunning results. It released composite images of star-forming regions like the Trifid and Lagoon nebulae, revealed thousands of galaxies in the Virgo cluster, and discovered more than 2,000 previously unknown asteroids in just 10 hours, including 7 near-Earth asteroids. For comparison, all other observatories combined typically discover about 20,000 asteroids in a whole year. Rubin is expected to uncover millions within just its first 2 years. And here's the exciting part. If another Oumuamua or Borisov, or something even stranger like 3I Atlas, enters our solar system, Rubin is almost guaranteed to catch it in real time. That means instead of scrambling after the fact, astronomers will have early warning, giving us a chance to prepare observations from the moment these interstellar visitors arrive. Every night, Rubin will scan the sky, generating trillions of measurements from billions of stars, galaxies, and asteroids. The data will be so vast it will raise questions we don't even know to ask yet. So here we are. From Galileo's first telescope to JWST and Rubin, we're watching the universe in motion like never before. Oumuamua showed us the possibility, Borisov confirmed it, and now 3I Atlas is here to push the boundaries even further. What stories will it tell us about other star systems? What mysteries will Rubin and Webb uncover in the years ahead? And that wraps up our journey with 3I Atlas, our third confirmed interstellar visitor, arriving just as the Vera Rubin Observatory begins its watchful mission and the James Webb Space Telescope sharpens its gaze. Each new discovery reminds us that the cosmos is not distant and still, it's alive, dynamic, and constantly sending us mysteries to solve. If you enjoyed exploring this with us, make sure to join us again here on Spaceverse, where we follow the universe's greatest stories, one star, one discovery, and one interstellar traveler at a time.